So this is the remediation for 7.1 slash 7.2, part A, where we're just graphing all of the exponential growth and decay functions, and we're understanding how their equations work out. So I'm going to do a few problems together, remind you about some things, and then everything else is for you to complete. So remind yourself about the exponential function. It's y equals a times b to the x power. Now, there might be some transformations, but what's important to remember is that whatever your base number is, that indicates whether you have a growth or decay. So if your base is greater than 1, that means you have a growth, because it's going to grow faster than 100%. But if your base is less than 1, we'll have a decay. So when I look at number 1, I notice that the base, the number that's holding up the exponent, is a 1/6. So the explanation for why this is an exponential decay is, whoops, that's a y, is because, well, that doesn't make any sense. It is a decay because the base is less than 1, because it's a 1/6. Okay? So the only thing I want you to be really careful about when you do your retake is sometimes I try to trick you guys, and I'll put down answers of like 3 times 2 to the negative x power. This is a trick question, right? If you look at this 2 to the negative x power, that really is 2 to the negative first to the x power, which means that your base, remember 2 to the negative first power, that's a reciprocal problem. This is really a 1/2 to the x power. So on your retake, watch out for any time I throw a negative exponent into the problem, because basically I'm trying to trick you. Warning on that one, huh? All right, the next section of your remediation talks about transformations as to whether they are moving right or left and up or down. But I'm not going to ask you about any other types of transformations for this section. So when I look at number 5, for instance, the x minus 2 is a horizontal transformation with that built-in negative. So that means this function is moving right 2 units. And then the vertical transformation is over here outside of the function all by itself. And that does exactly what you think it should do. So it's going to move everything up 1. So you can always check these on the calculator. That helps. And speaking of calculator, you're going to want to graph these using a graphing calculator and using your table. However, it is possible to do this one without a graphing calculator. It's just not a lot of fun. So first thing I would do is I would identify where the asymptote is located in this problem. And because there's no vertical shift, that means the asymptote is going to still be at the x-axis, or at y equals 0. So I'm going to use my highlighter. Remember, this is where the asymptote is. Ooh, I used a really thick highlighter for some reason, sorry. And this would be like an invisible boundary line where my function's not going to go through it. It's going to kind of scoot alongside of it. This is, I believe in this section they want you to figure out whether like you have growth or decay, asymptote, domain, range, all the good stuff. So with this one having a base of 2, that means we have an exponential growth, which we're going to confirm on the calculator in a minute. And then right here, you have an x plus 2, which means it's been shifted left 2 and up nothing. I don't know if they wanted me to write transformations down, but I did anyways. The left 2 shift is not going to change the domain or the range, but it is going to change where the points are located. So what I would do is I would go to my table on my calculator, and after you type your function into y1, you're going to get some ordered pairs. So, I don't have my key in front of me, but let's see, I can probably figure this out, right? I'm a math teacher. Let's plug in x equals negative 2. Now, if I did this mentally, I'd have 0, 2 to the 0 is 1, so I get negative 2, 5. That's one ordered pair that I'd plot. If I plugged in a negative 1, let's see, that'd be 2 to the first. 2, 5 times 2 is 10. All right, I seem to be heading in the wrong direction, so let me try plugging in the negative 3. Again, you can just take these right off the calculator. So negative 3 plugged in would be 2 to the negative first, which is like a 1/2. 5 times 1/2 is 2.5, and so on and so on, and I'd pull a whole bunch of points off of my calculator. So negative 3, 2.5, negative, oops, yeah, there we go. Negative 2, 5. I went out of order. I forgot about that. Negative 1, 10. And then you would notice as you keep plotting points, they would kind of scooch closer and closer to 0. And even the table gives up after a while. Oh man, oh gosh, that's so ugly. Okay, the table gives up and it kind of just calls it 0 after a while. Okay, pretend I can graph. Y'all know I can't graph. And you end up finding what's called the horizontal asymptote, which is one of the things they want me to identify. So the asymptote is at the equation of the line y equals 0, and it has everything to do with this vertical shift. So wherever that vertical shift is the location of your horizontal asymptote. Domain and range are common questions that we ask you guys, right? So domain is left to right, and domain of exponentials goes forever negative infinity to positive infinity. And the range is going to start at the asymptote, but the trick here is because it can't hit the asymptote, it scoots alongside of it, you have to use a parenthesis. So it's soft parentheses 0 to infinity for your range. And again, whatever the asymptote line is, it's going to start off your range. And I think that's all we had to do for this. Oh, it did say end behavior. Let me scooch in end behavior too. Because technically I could ask you all of that, couldn't I? Oh my gosh, come on, pen. There we go. End behavior. So remember, I give you part of the template. I give you this. Because we know enough about end behavior to know what I'm asking for. I'm asking for the far left side and the far right side. So, always end behavior wants left side and right side. So when I look on the left side of your function, which I can kind of still see here, the left side of the function is approaching the asymptote line, which remember is a height of 0. And then on the right side of the function, which I can't really see anymore, but it's up here, it just keeps going up, 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 up to infinity. So that's a big difference. For exponential functions, you're going to see that k value and the asymptote line, they show up a whole lot of places in this problem. You know, obviously in the graph it shows up, it's the asymptote line, it's part of the range, it's also part of the end behavior on one side. So very important location for you to spot when you start off the question. All right, I think that's enough examples for you. Go ahead and finish this up. And yes, you will need a graphing calculator to get the table, so make sure if you need access to that, that you're coming to see me before or after school.